Link state advertisements, we were trying to reduce this link state advertisements by creating multiple areas. When you create multiple areas, you get different type of LSAs, link state advertisements, that we saw. But there is one method to reduce the number of LSAs getting flooded. May not be a recommended method, where you can set the maximum LSA threshold. If it goes more than that, if LSAs are more than what you specify, then those LSAs will be useless, will be dropped, or there may be a warning for you saying the LSAs are too much, going beyond the threshold. It's an optional one. If you want, you can enable this, but the most important thing that I want to say here is this one: the metric. Ospf metric is cost. How the cost is calculated based on bandwidth. So there is a big explanation needed for this. Let me open my pin. Okay, here we go. You see, from A to C, I have two paths, one via B, one straight to C. If I'll have one gig link, everywhere, 1 gig, speed is 1 gig. According to router A, the cost to reach C via B will be 2. Cost on 1 gig link is 1. So 1 plus 1 is 2. Cost straight to C is 1. So Ospf will decide to pick this path as the best path. In the routing table, you will have only this path, straight route. Now I'm going to change the story here. Instead of 1 gig, okay, let that be 1 gig. This is 100 meg. 100 meg. Even now, if Ospf says this is the best route, then Ospf is a stupid protocol. This is 100 meg. This is 1 gig, 10 times bigger. 10 times bigger. But Ospf will say this is the best path. Even now it will say this is the best path. Do you want this? You don't like this, right? How can 10 times bigger link cost is 1 and 100 meg, which is 10 times lower, cost is 1? By default, this is how Ospf treats the cost. This is how the Ospf calculates the cost. Why is it like this? The reason is the reference bandwidth. If you see how the cost is calculated, it is the reference bandwidth 100 divided by the actual bandwidth on the link. Now when you have 100 on the numerator, And in the denominator, if you have 1000, which is 1 gig, you get answer as 1 only. It won't take the decimal fraction numbers. It will consider as 1. It won't take that 0.001, those things and all, it won't care. It will take it as 1. So the cost when you have 1 gig is 1. And now the cost when you have this bandwidth 100 meg is also 1. You see why Ospf is still holding this path, why it still says this is the best path, because this is how Ospf calculates. The problem is the reference bandwidth. The reference bandwidth by default is 100 meg. That's the default reference bandwidth. Why 100? When Ospf was introduced, when Ospf was introduced, 100 meg was something unreachable, infinite, can't be achieved. That is how the condition was. The network technology was not that grown big, and we were having like 56 kbps wire. Very thin phone wires, and then it will support only 56 kbps. With a phone wire we used to have internet. In my days, in olden days, BSNL dialer will be there on the desktop. Windows 95 was the operating system. Windows 85 or 95, I don't know, I think 95, Windows 95, 98. 98 came later. So the dialer we used to double click, and then it will dial a phone number. You will literally hear a sound, and then it will connect. You can hear the dialing sound. With the 56 kbps, you will get an internet. Very slow. Today, if you don't pay bill in India, you might have had a 100 meg speed, but when the period ends, when you don't renew your subscription, then 100 meg will come down to 1 gig. 1 meg. 1 meg speed. 1 meg speed. That 1 meg speed itself is not enough to open one page today. 1 meg itself is not enough. But on those days, the entire internet will be running on 256 kbps. 56 kbps. 56. Just 56. Today, free internet is given with 1 meg. And no one is ready to use it. Because it's difficult for a page to open. Today, HTML pages are too colorful and heavy weighted. So on those days when 56 kbps was there as an internet speed, 56 kbps is many 10 times lower than 100 meg. Many hundreds times maybe lower, smaller. So they didn't imagine that we will grow this fast and this big when this algorithm was introduced. When this algorithm was decided to calculate the cost. So they said 100 as the numerator, and they say if you keep 100 as the numerator and try to decide this path is better or that path is better, that will be more correct. Right, so 100 was kept as a metric, 100 was kept as a reference. 100 was kept as a reference. That 100 has become problem today because we got 1 gig, 10 gig link also we got now. 10 gig also we have. There are some special cables in Cisco, we have 40 gig. Just one wire can take 40 gig of data. So we have to now change this numerator. If you will change the numerator, then Ospf will become wiser. So what will happen, if I change the numerator? Let me show you. If I change this numerator to 1000, what will happen? Here the cost will be 1, because 1000 by bandwidth is also 1000 meg. If you write in meg, it will be 1000. 1000 by 1000 will be 1. 1000 by 1000 will be 1. This one, 1000 divided by 100 is going to be 10. Cost is 10. Now Ospf will say, this I don't want. This is 10. I'll go via this way. 1 plus 1 is 2. This is the best path. See? It's an eye opener for Ospf. You just change the numerator. We call this numerator as reference bandwidth. You change the reference bandwidth from 100 to 1000. The Ospf will be able to differentiate 100 meg and 1 gig. Earlier it was not seeing as different. Earlier it was same. For Ospf earlier it was same. Let me show you this. I want to demonstrate this. According to R1, to reach R3, both are same. It will say it will go via the below path. Below path initially. The cost will be seen as 1. Even though it is fast Ethernet, smaller in bandwidth, the cost on this link and this link will be seen as 1. I want to show you that first, then I will go to the next level. Ten dot 12.0.1 255.250 interface F 1/0 IP address is 10.13.0.13.0.1 252500. So I just put the IP addresses like this, and I also have a loopback interface for testing here. We'll put 3333 here. 3. Yeah. Now let us configure router 2 quickly. Interface loopback 0, IP address 2.2.2.2, interface gig 00, 10.12.0.2, interface G2/0, 10.23.0.2. So these are the IP address we have configured. Let's go to router 3. Three 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 three. 10.23.0.3. Interface F1/0. Done. So we got our IP address configured, and now we need to enable Ospf. I'm going to enable Ospf under the interface. Almost all the routers have got 3 interfaces, 2 physical and 1 loopback. So let me use Notepad. Enable config T interface loopback 0, IP Ospf1 area 0, and then interface gig 00, IP Ospf1 area 0, and then interface. Oh, what did you say?
IP address for loopback 0.
IP address is already configured, no? IP address we have already configured, no?
Okay, yeah, sorry.
I'm just enabling Ospf alone.
Yes, sir.
And show write to memory, show IP Ospf interface brief. Copy, don't cut. Let's paste this on R1. Alright, so these are the 3 interfaces that runs Ospf. Similarly, on router 3. And now on router 2, we got this G instead of F. G2/0. Alright, so I'm waiting for Ospf to form neighbor now. I'm expecting two neighbor. One with router 1, another one with router 3. One neighbor is already done. Another neighbor is also come. That's nice. Let's go now. Listen. From R1, if you check the routing table, show IP route Ospf. I'm interested in router, the route that goes to 33333. If you see, it says I go straight to router 1. I go straight to router 3, this address. Router 1 says to reach 33333, I go straight to this address. Meaning it is not going via router 2. It's not going via router 2. Poor Ospf. Can't you see? You got Ethernet on the top and you got fast Ethernet at the bottom, and you still say I want to go via fast Ethernet. Ospf is not having clear vision. For Ospf, cost looks same. You see, this link, physical link is 1 and loopback is 1. 1 plus 1 is 2. So Ospf says the cost is 2. Router 1 says, router 1 according to Ospf, router 1 finds this is the best path because for this cost is 1 and the loopback is 1. 1 plus 1 is 2. If I shut down this port, what will happen? It will choose this path 1 plus 1 plus 1, which will be 3. I want to show you that. Let me shut down this port. F1/0 of router 3. Interface F1/0 of router 3 shut down. And now if I go back to router 1, earlier you were going straight to router 3 via fast Ethernet. Not with gig Ethernet, fast Ethernet. Poor Ospf. Now it says, I go via gig Ethernet and the cost is 3. So what I said is same. Matching. For fast Ethernet also cost is 1, gig Ethernet also cost is 1. That I proved now. You see? 1 plus 1 plus 1, 3. Earlier when it was going straight, it was only 2. When it was going straight like this, it was 1 plus 1, 2. So let me bring back the interface. Bring back. No shit. So I have just proved that for gig Ethernet also cost is 1 according to Ospf. Fast Ethernet also cost is 1. It is all because of that reference bandwidth. The algorithm's reference bandwidth is 100 by the actual bandwidth on the link. That's the problem. 100 is what kept in the numerator, and now whatever the number you do in the denominator, it's of no use. The answer is going to be 1 as per the algorithm. It won't use fractions. Now if you will change the numerator to maybe 10,000 instead of 100, if I change to 10,000, what will happen? 1 gig is 1,000, so it will become 10. This will become 10 and this will become 10. If I change, okay, and then what will happen to this 100 meg wire? For the 100 meg wire, this is 100 meg wire. Fast Ethernet is 100 meg. Remember, fast Ethernet is 100 meg. Gig Ethernet is 1000 meg. Now when it is 100 meg, then the cost is going to be 100. So this is 100. This is 10 plus 10 plus 1 is 21. You understand? Now Ospf will say this is the best path because more bandwidth. It can now able to differentiate between fast Ethernet and gig Ethernet. Do you have any question? I'm going to do this and show you. Do you have any question before I do this? Did you understand what I'm trying to present to you today?
Yes, sir.
Thank you. Now, if you're changing on one router, you have to change it on all the routers. How do we change that? I told you it's a reference bandwidth. The numerator value is a reference bandwidth. We are going to use now 1000 as a reference bandwidth. If I use 1000 as a reference bandwidth, the cost will be 1 for gig Ethernet and 10 for fast Ethernet. Is it right? Yes. So I'm not going to use 10,000. Let's use 1,000. 1,000, we are going to change this numerator from 100 to 1,000, and the actual bandwidth will be copied here. So actual bandwidth is 1,000 here, so cost will be 1,000 by 1,000 is 1, 1,000 by 1,000 is 1. Here 100 by 1,000 by 100, the cost is going to be 10, and now Ospf will say this is my route. Let's see. This is the command. Router Ospf1 auto cost. How the cost is calculated? Automatically, right? Did we calculate any cost when you enable any routing protocol? No. If you see EIGRP, dual algorithm does it automatically. RIP does it automatically. Metrics are calculated automatically. So the command will be like auto cost only. How the cost is calculated? Automatic. But there is a protocol which is also link state routing protocol that never calculates the cost automatically based on bandwidth. They don't calculate based on bandwidth or delay. ISIS don't care about your bandwidth or delay or load or empty. No, never cares. So their auto cost is never auto cost reference bandwidth. See how easy to remember this command. These are the terms I was using to explain this. Reference bandwidth. That's the numerator value. Auto cost reference bandwidth. The default is 100. I'm going to say now 1000 meg. See, it's in megabit per second. Now this needs to be done on every device. So I'm copying this to a notepad. Enable config router Ospf1 and write to memory. Let's do it. Alright, so see, it also says you have to do it on all routers, across all routers. Boom. Done. Auto cost reference bandwidth. You need to do it on all routers. We have done it. Now if you see, router 1 will say show IP route Ospf. It says I will go via router 2 only, because if I go via router 2 it is just 3. Cost is only 3. One plus this loopback one. But if I shut down this port, what will happen? What will be the cost via the state path? If I shut down this, what will be the cost shown in the routing table when this has the gateway? What will be the cost? 11. 10 plus 1. Let me show you. So 11 is costly. This way cost is 11. This way cost is 3. That's why it is taking this path. But if I shut down this link, now you will see 11 as the cost. Now going back to router 1, see, it's now going straight. No, give some time. Yeah, it has come. It's going straight to router 3 and 11 is the cost. So this differentiation between fast Ethernet and gig Ethernet is only because you change the numerator to 1000. Earlier it was seen as same. Both were seen as same. Alright. Now it will go back to router 2. Yep. It is now going, no, still not changed. Give some time, it will come. When I say no shutdown, so it has now switched from 3 to 2 because the cost is lower. Hope you understand this reference bandwidth in Ospf. Yep. You can also change the cost on the interface level. If you want to give manually cost, see, we did auto cost. Usually we depend on the automatic calculation. For automatic calculation, we said use this numerator, use this reference bandwidth. We said this. But if you want to go to every interface and say Ospf, this is the cost, you no need to calculate, I'll give you the cost. So you want to prefer a route, you give low cost. The other routes, because of the high cost, they will be ignored. So this is interface level. IP Ospf cost. See, let me do and show you. Right now, gig Ethernet path is seen as best path, no? Now I'll go to this fast Ethernet. I'll decrease the cost. Right now it is going via gig Ethernet because the cost is 3. I'll go to interface F1/0 IP Ospf cost. I'll give 1. Likewise, I'll go to router 3. Interface F1/0 IP Ospf cost 1. So I have given 1. Even the auto calculated cost is 10. Because I gave 1 as an administrator, I have given this. So it obeys the administrator, not auto calculation. Now let's go and check that routing table. Show IP route Ospf. 333. Look at this. It goes straight to router 3 because the cost is 2. It's going by F1/0. So you can manually configure a cost on the interface by using this command IP Ospf cost. Mostly we don't do this. We try to go with the auto reference so that even if you resign the job, the next guy will know what is really going on. If you do just few configurations on one or two interfaces, then he may not find it. Troubleshooting will be difficult. If you leave it to auto reference, auto cost calculation, it is better, right? So you may use both of these or any of this, it's up to you. In this chapter, I think we have covered all the other things.